All right, so let's take a look at the derivative rules for sine and cosine. So the derivative of sine is sine of something. The derivative of the sine of whatever it is cosine of that same piece times the derivative of that. So if this just happened to be a x to the third, it would be the cosine, the derivative would be the cosine of x cubed times whatever the derivative of x cubed is. So our example down here, we have y prime equals sine of 7x. So y prime would be cosine of 7x. And then we multiply by the derivative of that inner piece, so 7. So remember, the derivative of sine is cosine of that same piece. And we're multiplying that by the derivative of that inner piece. So the derivative of 7x is 7. All right, over here we have cosine, and the derivative of cosine of something is negative sine. So the way that this one works here, we have y prime is equal to, right, we have a cosine, so that becomes negative sine of 5x to the fourth. That piece stays the same, and then we multiply by the derivative of the inner piece, so 20x cubed. So remember, you have your d outer, right? The outer function is cosine, so the derivative of cosine is negative sine, and then times d inner, the derivative of this inner piece here, being 20x to the third. So sine and cosine are actually kind of interesting also. There's another thing that kind of happens here with sine and cosine derivatives. So if I just had the function sine of x and I found the derivative of that, I get cosine x. And when I find the derivative of cosine x, I get negative sine x. If I took the derivative of this, well, the derivative of sine is cosine, so the derivative of negative sine is negative cosine. And then now that I'm back to a cosine, if I took the derivative again, it would change signs again. So we would go from negative cosine x to positive sine x. And this thing is just going to kind of keep going in this pattern, right? As we move down, right, and go through our derivatives, all of a sudden this pattern cycles back to the top. So this is kind of a very repetitive pattern with these trig derivatives. Sometimes honestly it's a little more helpful just to know this list here to be able to find the derivatives, because that way you don't have to actually think about what the derivative is. You just look at your list and grab the one that you're looking for. So try a couple practice problems out and we'll see how this goes.